Earth's magnetic field is generated by a dynamic process called a geodynamo, and its cessation would have severe cascading consequences for the planet and life on it. Several other planets in our solar system also have magnetic fields, though the mechanisms and strengths vary greatly. How Earth generates its magnetic field. The geodynamo is the product of three main ingredients operating in the planet's core. A conductive fluid. Earth's outer core is a vast, churning ocean of molten iron and nickel, both of which are excellent electrical conductors. Planetary rotation. The Coriolis effect, caused by Earth's spin, organizes the flowing metal into spiral convection currents. An internal energy source. The motion of the molten metal is driven by immense heat escaping from the core. This heat comes from two primary sources: energy released by the solidification of the inner core and the decay of radioactive elements within the planet. This combination creates a self-sustaining feedback loop. The movement of the conductive fluid generates electric currents, which in turn create a magnetic field. This magnetic field then influences the flow of the molten material, causing it to generate even more electric currents, and so on. Effects: if Earth's magnetic field stopped. If the geodynamo were to stop, the Earth's magnetic field would decay over thousands of years, leading to a number of catastrophic effects. Long-term effects. Atmospheric loss. The magnetosphere shields Earth's atmosphere from the solar wind, a stream of high-energy charged particles from the sun. Without this protection, the solar wind would gradually strip away our atmosphere over millions of years, as is believed to have happened to Mars. Increased radiation. High-energy cosmic rays and solar particles would bombard the planet's surface. This would result in a massive increase in cancer rates and mutations in humans, animals, and plants, leading to a long-term collapse of ecosystems. Technological disruption. Power grids, satellites, and communication systems would be extremely vulnerable to intense solar storms and radiation, causing widespread failures. Immediate effects: navigation failure. Compasses would stop working, and migrating animals that use the magnetic field for navigation would become disoriented. Intense auroras. The auroras would expand beyond the polar regions and become more frequent and powerful for a period, as solar particles would be able to interact with the atmosphere over a much larger area. The magnetic field has, in fact, weakened and reversed its polarity many times over geological history. Though this is a slow process that takes thousands of years, it shows that the geodynamo can and does undergo significant changes. Magnetic fields on other planets. An object's magnetic field is a powerful clue to what is happening inside it. Several other planets in our solar system have magnetic fields, generated through different mechanisms. Planets with magnetic fields. Mercury has a weak magnetic field generated by a dynamo effect in its large iron core similar to Earth, but it rotates very slowly. Jupiter and Saturn. These gas giants have extremely powerful magnetic fields generated by the movement of liquid metallic hydrogen in their interiors, which is compressed under immense pressure. Jupiter has the largest and strongest magnetic field in the solar system. Uranus and Neptune. The magnetic fields of these ice giants are offset and tilted significantly from their rotational axes. Scientists believe this is generated by a dynamo in a layer of electrically conductive fluid, likely a mix of water, ammonia, and methane, rather than a metallic core. Ganymede. This moon of Jupiter is the only moon in the solar system known to have its own internally generated magnetic field, though it is weak compared to Earth's. Planets without magnetic fields. Venus. Despite having a liquid iron core, Venus has no measurable, global magnetic field. This is likely because it rotates too slowly to drive the necessary convective currents. Mars lacks a global magnetic field today, though there is evidence it possessed one in the ancient past. Its core has solidified, causing the dynamo to cease. The loss of its magnetic field is the leading explanation for why Mars lost its atmosphere and surface water.